Good morning, student. To the another class. Today we will study about the paper chromatography. Supposed to be the first basic chromatography for the isolation of the varieties of sample. Paper chromatography generally we separate the substance, unknown substance, which generally carried out onto the paper. Which can be used as a stationary phase along with the certain solvent system that can be used as a mobile phase. The principle of this paper chromatography is mostly based on the partition coefficient. The partition coefficient actually defined as the ratio of concentration of the solid molecule along with the immiscible solvent. That means the way the solid molecule get partition in between the two immiscible solvents. Okay, so this Cs by Cm that define the partition coefficient, that is C for concentration of solute in solid state, that is solid phase, and the concentration of solute in the mobile phase. Okay, so generally the partition coefficient is the ability of a solid molecule to get partition between the two immiscible solvents. So two immiscible solvent, generally they are insoluble with each other, and when we add our solid molecule, the solid molecule which is more soluble into that particular solvent will tend to go in that particular solvent. That means the solubility will increase the flow of solid molecule towards that particular solvent, and the solid molecule which are less absorb or less soluble into the solvent system, the fewer or less molecule will move into that particular solvent. Okay, so the solubility is most important factor. Okay? So the solid molecule that is more soluble into a particular solvent will tend to go with that particular mobile phase. Okay? So the partition is the way by which the solid molecule partition itself between these two particular solvent system. Right? So the solubility is actually the main factor. In case of its principle, as I told you, is mostly the partitions, okay, rather than the adsorption. Okay? Partition and adsorptions are the two things. In case of partition, between the two immiscible phase solid molecule, partition itself, और वो जहाँ पे ज़्यादा soluble होगा उस area में वो will move into that particular solvent phase. In case of adsorption, particle molecule get adsorbed over the stationary phase, right? So the stationary phase is what? Mostly the paper, that is the layer of a cellulose, okay, which contain a moisture that act as a stationary phase, okay, and the solvent system or the buffer system is used as the mobile phase, right? So in case of this particular method, we need what? We need basic requirements, that is a paper, stationary phase, application of sample, mobile phase, developmental techniques, and then finally the detection or the visualization of a sample. So stationary phase and the paper type generally used, it is mostly the Whatman filter paper. Okay, we are all familiar with this. These Whatman filter paper comes in a different grades, okay, based on the size and the filtration capacity, up to the Whatman filter number 1 up to the 42. Okay, these are the different size and the grades of the Whatman filter paper, which consist of mostly the 99% of the cellulose. Okay. The paper that we generally use will depends on the nature of the sample, okay, and the type of the solvent generally we use. Also, the way we carry out the analysis, whether it is the quantitative or the qualitative analysis, and lastly the based on the thickness of the paper. So these are the different factors which helps in selection of the paper that generally we use for the chromatography. The way we can prepare a particular paper is based on the type of the sample generally used, right? We cut that paper into desired shape and size, okay, and then mark the paper from the bottom of 5 cm, okay, and we put the sample around 2 cm apart from each other. Okay, so we cut the sample into particular size, then we mark with the pencil top from the bottom up to the 5 centimeter, and we keep the samples 2 centimeter away from each other so that they cannot get diffused, right? So the sample is applied on by using the capillary tube or the micropipette, so that the narrow needle can be used, which create the small spot on the filter paper. Generally we use the very low concentration so that we can avoid the formation of the larger zones. In this case, here you can see this. The zones are quite larger and the diffuse. To avoid such things, generally we use very low concentration of the sample molecule. The sample molecule, once spotted over the paper, generally keep for the drying, so that sample molecule gets stuck to the paper and concentrated. So therefore it gets dried, and then we'll put that into the developmental chamber for the analysis, right? This is the main important factor, that is the mobile phase. Mobile phase, generally the solvents are the buffer solutions. Okay, we have two types: is hydrophilic and the hydrophobic. Based on the solubility of the sample, we can use any one of this particular mobile phase. Here you can see the mixture of different particular solvent, isopropanol and the ammonia and the water in this particular ratio, methanol and water in this particular ratio, and butanol, acetic acid and the water together in this particular ratio, right? So different types of the solvent system, they mix together in a particular amount of the ratio. Hydrophilic mobile phases generally is diethyl ether and the cyclohexane, and the kerosene and the 70% isopropanol. So these particular are the different types of the solvent system that act as a mobile phase, and along the flow of this mobile phase, generally your sample or the solid molecule travel along the flow of the mobile phase. So the mobile phase is actually the more important. Once we have done the preparation application of the sample, we put that paper into the particular chamber, that is called the chromatographic chamber. So chromatographic chamber is mostly made of the glass, plastic or the steel generally, right? Most preferably we use the glass tanks, right? And this before carrying out the actual chromatographic process, we have to saturate the chamber with the solvent that generally we will use, so that the solvent gets saturated over the whole area of the chamber. Therefore the separation will be more easy, and the well separated band will be produced by making the saturation of the chromatographic chamber, right? So once all the previous steps have been finished, we carry out the actual separations, and after the separation we need to detect the particular solid components onto the paper. For that, in a development technique, generally we disperse the paper into the solvents, but taken care should be is that the spot should not get deep completely into the solvent. Otherwise what will happen, the solvent get dissolved into the solvent and move all down to the solvent system, so there won't be any spot on the paper. So we just dip a small portion of a paper into the solvent, but not the sample spots. The solvent will rise up along with the flow of the mobile phase, and generally we have to run the solvent until the 2/3 of the portion of the paper for the better and the efficient result, right? There are the variations in this paper chromatography, that is mostly the ascending techniques. Like this is the whole system of a chromatographic chamber, where we have put the paper, okay, along with the spot, and down is what it is, the solvent system. So solvent will rise up against the gravity, right? So the portion of the paper that keeps at the bottom, okay, that means the solvent get rise against the gravity. This means it is ascending. Solvent is ascend along with the paper, therefore it is called as the ascending techniques. That is, solvent move down from the upward position, right? In a descending technique, this is actually carried out in a special chamber where the solvent is kept at the top of the particular area. Okay, here you can see in this particular chromatography, at the top we put the solvent system. In the solvent system, they descends down, okay, along with the gravity. So from the top it reaches to the bottom, therefore it is called as the descending chromatography. Okay, the more advantage of having descending technique is the development, and the suppression is the faster, right? So this is what the basic way of carrying out the paper chromatography in two ways. One is the ascending and the descending. In ascending paper chromatography, solvent is at the bottom. In descending technique, solvent is at the top. So solvent movement against the gravity or along the gravity will determine as whether it is ascending technique or the descending technique. After the development process has been done, we generally have to detect the samples. Okay, if the substance are already colored, then we don't need to do any detection methods. Okay, because the color spot we can already see. But for case of colorless substance, okay, we have to use certain methods to make them visualize or the colored, right? So mostly we have non-specific method. There is the physical method. Generally we use the iodine chamber method and the ultraviolet chamber. Okay, so in the particular chamber we put the iodine compounds. So iodine vapor generally attached to the paper, and where the spots or the samples are there, this iodine binds, make the reaction, give the colored product. In case of a fluorescence compound, we put the whole chamber, the whole development technique inside the UV light system. So UV light will create the fluorescence on the paper, and the fluorescence band you can easily observe. Okay. So here are some examples. Generally we use it for the different types of detections. Mostly generally in case of amino acid, okay, we use the neon hydrogen. Okay, that makes the particular colored spot like this. Okay, in case of amino acids. So neon hydrogen reacts with the amino acids and produce a stable colored complex, that is called the particular neon hydrogen complex, right? In case of ferric chloride, we use phenolic compounds, dragon alkalides, and the 3,5-dinitrobenzene glycosides, right? RF value is actually the way to calculate the particular distance traveled by the solid in the solvent. Okay. Once the desired amount of a run has been finished, okay, we'll take out the paper and then mark the area where the solvent have traveled. That is called the solvent front. Okay, and in comparison or reference to the solvent front, we also mark the area or the distance traveled by our sample molecule or solid molecule. So the RF value will be calculated is by the distance traveled by the component, the distance traveled by the solvent system. Okay, so this will give you the determination of the particular distance traveled by the solid molecules, and we can identify accordingly the samples, right? So this is what particularly the way we generally do it for the isolation methods, right? So in order to study the basic process of whole chromatography, okay, we take an example of separating the plant pigment from the paper chromatography. For this, we generally select a paper of a desired shape and size. We will mark the particular area, okay, down from the bottom, okay, and we will mark the center area where we will keep our samples. Okay, distance between bottom, it should be around 2 to 4 centimeter, so that the particular area should be remain there for the dipping of the solvent. So with the help of a capillary tube, we will take the sample, okay, and this sample we can put over the center of where we mark the with the pencil. Okay, so once the sample has been put, okay, so generally sometimes we have to add the more samples in the order to have concentrated pan. Once this has been done, we have to wait for a drying of the samples. Okay, then we will prepare a particular solvent system. In case of this plant extract, we'll generally use the propanol water system. We add into the development chamber for the saturation, okay, before carrying out the particular process. So saturation is done, and then the solvent system along with the water, propanol, is generally added. Okay, so in the order to make them the saturate the whole chamber, right? Mixing is properly done, so therefore the saturation should be proper. So once this has been done, okay, the chamber is ready for the chromatographic process. So we'll put the paper into the chamber, we'll close the lid of a chamber, and then we allow only the half portion of the bottom to be dipped into the solvent. Okay, so as the solvent rises against the gravity, it takes the sample along with its flow. So the sample gets separated according to their partition coefficient and the solubility. So this at most takes 1 to 2 hours depending on the sample. Take out the papers after that, mark the area where the solvent have been traveled. Okay, that is called the solvent front. Then we will mark the center of the spots, okay, and we will measure the distance along with the solvent front. Okay, so the center point is generally taken for the determination of the distance traveled by the sample molecule. Okay, so this total is given as RF value, which is distance traveled by the solid from the original line and the distance traveled by the solvent front from the original line. Okay. So main idea of having the larger RF value, that is the greater distance, that means it is more soluble. Shorter distance just means it is less soluble, therefore it travel less. So this RF value is actually give the idea about the solubility of a sample. So larger RF value, that means the solid molecule is more soluble, and the smaller RF value that describes the solid molecule is less soluble. So these are what the RF value will give you the idea about the paper chromatography. In case of its application, different types of applications are been identified. The separation of the mixture of the drugs, we can separate different mixtures of a drugs, separation of the macromolecules like carbohydrates, vitamins, antibiotics, and the proteins. Then identification of drugs, we can identify new drugs depending on its separation. Along with, we can also identify the impurities from the samples, and finally the analysis of metabolites of drugs in blood as well as in the urine. So there are the vast area in that we can use the chromatography for the separation and the identification of a particular samples, right? So this is all about the overall paper chromatography. Hope this is all understand to you. We will continue in the next class with another topic. Till then, thank you. Goodbye.